Hi, in this lesson, we'll see how to find the distance between 2 points using the distance formula. We'll use these two equations, these two questions, to understand how to find the distance between 2 points using the distance formula. But before we get started with these two questions, I will want us to understand the Cartesian coordinate. Here is my y-axis, and here is my x-axis. So that if this is my x-axis, let's name this point x1, and the other point here, let's call it x2. Let's call this point y1, and let's call this point y2. So that if I trace this down here, I will have this point here. I want to refer to this point as x1, y1. And also, if you trace this down here, you have this point here, and I also want to refer to this point as x2, y2. Now, if you look at it carefully, I can now join these 2 points together. Then they begin to form like a right-angled triangle. Now, if this is a right-angled triangle here, look at this line here. This line makes the hypotenuse. Let's call this line C. And let's name this point. Let's call this line A, and let's call this line B. From my Pythagoras theorem, from Pythagoras, we know that our C squared is equals to A squared plus B squared. Now, and if C squared is equals to A squared plus B squared, obviously, my A here moves from x1 to x2, so that my A is equals to x2 minus x1, and my B will be equals to, my B moves from y1 to y2. My B also will be equals to y2 minus y1. Then I can conclude that C squared, which is the length of this line and the distance between these 2 points, is the same thing as x1, x2 minus x1 all squared plus b squared, that is y2 minus y1 all squared. So that C itself, to find C, we'll be taking the square root of both sides. C now becomes the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, you see how they came about the distance formula. Here is the distance formula. Now, let's go ahead and apply the distance formula in our questions. If this is the first time you are coming across our channel, please do not hesitate to hit the subscribe button. That way, you'll be sure to get notified anytime we create content as this, and also you encourage us to do more. Thank you. Now for question 1. If I have my 2 points, point P and point Q, let's draw the Cartesian coordinate once again. Now, the first point is at 4. This is the x-axis, and here is the y-axis. I have my first point at 4 on the x-axis, and the second point Q, I have a 5 on the x-axis. And for my y-axis, I have a point at 1, and also the second point, I have it at what? At 4. So here is 1, here is 4, and here is 4, here is 5 on both y and x axis respectively. So that my point P, if you trace this point down here, this is my point P, and if you trace this one up here, this becomes my point Q. Now, the same thing happens just like we saw in our distance formula. There is a distance between P and Q. The line PQ, which is the distance between P and Q, will be the same thing as the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So that PQ, my PQ will become, my x2 in this case is 5. That's the square root of, my x2 in this case is 5 minus 4 all squared plus 4, which is my y, here is the 4, that's my y2 minus 1 all squared. So that the line PQ, the length of that line, will be given by the square root of 5 minus 4, or that's 1, all squared, plus 4 minus 1, that's 3, all squared. So that my line PQ will be given as the square root of 1 plus 3, which is the square root of 10. Now, I want to take the second question, but I want you to pause this video and try your hand on the second question. Okay, for the second question, we have 2 points x and y. Let's draw the Cartesian coordinate once again. I want you to constantly draw the Cartesian coordinate. That way you can visualize the points. Now, but if you look at this particular point for x, you notice that they both fall on the negative axis. This is my y-axis and this is my x-axis. Now, here is on the negative part of x-axis, I have a point x that's minus 1. This is minus 1. Let's tag this minus 1. And here, let's tag this minus 2. Now, for the y part, I have, so if this is, I'll assume this is my point x falling to this point. And also, I have, for the second point, it has a part of its coordinate on the x-axis, let's call this 2, and the other, let's call it here, let's call this my minus 5. So you trace it down this way, you see that if you trace down, this is 2, and here is minus 5. So I can call this place my y, so that the point here is my line x, y. Now, let's use our distance formula. Our distance formula says that d is equals to the square root of x2 minus x1 all squared plus the square root of y2 minus y1 all squared. Now, d now will be equals to the square root of x2 minus x1. Now, let's label it carefully. Now, for here, this is my x1, y1. Here, this is my x2, y2. So my x2 in this case is 2 minus 2 all squared, plus my y2 in this case is minus 5 minus, and my y1 is minus 1 all squared. So that my d, which is the distance, is equals to the square root of 2 minus 2. That's 2 plus 2. That's 4 all squared. And minus 5 minus 1. That's minus 5 plus 1. That's plus minus 4 all squared. Now, d now becomes the square root of 4 squared, that's 16, plus the square root of 4 minus times minus is plus, and the square of 4 this time again is what? Is 16. So that d now is equals to the square root of 32. And the square root of 32, if you go by it, d is equals to 4 root 2. Thank you for staying with us, and if this is your first time of coming in contact with our channel, please do not hesitate to hit the subscribe button and also the notification bell. That way, you'll be notified anytime we create lessons like this. Thank you.